This week, I will be studying simple harmonic motion by building a pendulum. One of the essential components of a simple pendulum is a small, dense, heavy object that will act under the influence of gravity. I use these two metal objects and tie them together using this string. Next, I'll be tying my mast to the end of this long rope, which I have marked at several different lengths. This is important because the time period depends on the length of the rope and the acceleration due to gravity. The acceleration due to gravity, or g in this equation, is what we are solving for. We will solve for it using the length of the rope and the time intervals that it takes to make 10 oscillations. Another factor we must consider is the angle at which the pendulum is raised. In this experiment, we will be using 10 and 20 degrees, and I have marked these values on a sheet of paper. This is my full pendulum setup. As you can see, there is nothing touching the weight so that it can swing freely. This is a demo for the first trial of my experiment. On this trial, we are using 10 degrees to raise the pendulum. I made sure that the stopwatch was turned on my phone, and I used my sheet to measure out 10 degrees. 0 degrees is when the pendulum is at rest and not moving. This means that no forces are acting on it at this time. I raised the pendulum to 10 degrees, and I started my stopwatch. I counted the amount of oscillations that the pendulum made, and once it had made 10 oscillations, I stopped my stopwatch, making note of the time. For my first trial, it took 20 seconds to do 10 oscillations. The length of my rope is 80 centimeters. I will repeat this trial 3 times and record the average time that it takes to do 10 oscillations at 80 centimeters. Then I will repeat this same process with the different lengths of the rope that I have. These lengths are 100 centimeters, 120 centimeters, and 140 centimeters. I performed the experiment twice. The first time I raised the pendulum by 10 degrees, and the second time I raised the pendulum by 20 degrees. I performed 3 trials for each of the rope lengths. I found the average time it took for each of the rope lengths, and then I divided that number by 10. This gave me the time period, or t. This is important because it relates back to the initial equation that we were using. Now that I have the t, or time period values, and the length of the rope, I can calculate g, which is what we were solving for in this experiment. I calculated g for each of the time periods that I had calculated. Next, I found the average of my accelerations, and this number was 8.590 meters per second squared. This is a little bit lower than the standard value of g. However, this can be accounted for due to error in the experimental setup or error in calculation. In conclusion, I found that as the length of the rope increased, or the x-axis values on this graph, the more time it took for the oscillations to take place. In other words, the longer the rope, the more time it will take. And then, this will have a direct correlation on the acceleration due to gravity. It doesn't matter the amount of degrees that you raise the pendulum, what really matters is the length of the rope. Overall, I believe that my experiment was a success. I learned a lot about simple harmonic motion. Thank you for watching.